So the next section that we're looking at is going to be about solving equations. It starts out, you see it's saying solve each proportion. So this is a proportion because it's just two fractions on either side of an equal sign. And because of that, one of the things that we can take advantage of is the thing called the cross product rule. And so lots of people have heard of and used the term cross multiplication. Sometimes they're correct about using it, sometimes they're making up their own version of math, which of course gets them, well, let's just say a creative answer that doesn't necessarily match what's really going on in reality. So one of the things we want to do, well, the thing that we want to do is to figure out what this number x would be in order for one side of the equal sign to be exactly the same as the other, because that's what the equal sign means. It means that you have the same value on either side. That concept's easy to lose once we start dealing with x's and x squareds and expanding and all this other stuff. But that's literally what we're doing. We have a situation where we want to say what x has to be in order for both sides of the fraction to be exactly equal. Lots of different ways to prove that, but let's not overcomplicate things for now. To solve for an unknown variable, like x in this case, it needs to be on the top and it needs to be isolated or on its own. So if we take advantage of this cross product rule, we're going to multiply x by 5 to get 5x, okay? And we'll, again, we want to have it on its own, so we might as well multiply 2 by 25 to get 50, okay? And we use the cross product rule in both cases. We now have x on the top, but it's not isolated. So the next thing that we need to do is, well, we want to know what 1x is, but we know what 5x is. So if we just divide both sides by 5, or whatever number is attached to the x, guess what? 5 is going to cancel out to become 1, right? It's not going to cancel out, it's going to divide out to be 1. And we're going to be left with x is equal to 50 divided by 5. Another way to say 50 divided by 5 is the number 10. And let's see if that makes sense. Going back to the original question, to get from 5 to 25, we would have multiplied by 5. And so what would 2 times 5 give us? Well, it would give us 10, and there you go, we got it. The next type of equation that we're looking at is slightly different. We're going to keep in mind that this is an equation like a scale. So whatever we do to one side of that equation, we have to do the same thing to the other in order for this scale to stay in balance. I have 3 attached to the x. I also have plus 4 over here. And what I want to do is isolate x, or get it by itself. So what I'm going to try and do is remove things that are over on that left-hand side. And if we think about this like a scale, it's like subtracting 4 from the left-hand side would make that number equal 0, and therefore we'll call it disappear. And if you do it to one side, you have to do it to the other. So what we're left with is 3x is equal to 10 minus 4. Therefore, 3x is equal to 6. And the last thing that we want to do is we want to know what 1 of x is, not 3 of x. So we divide both sides by 3. X is equal to 2. With all equations, what we should do is to take the answer that we got and substitute it back into the original equation. 3 times 2, we said x is equal to 2, right? So 3 times 2 makes 6. 6 plus 4 makes 10. The left side equals the right side. All right, the next type of equation that we're going to look at is another step more complex because, well, one way to do it would be to expand out this number in bracket before we solve the equation. So there's just a few more steps. All right, so we're going to expand the rest of this, and 4 times k over here is 4k. And 4 times 8 is 32. Just make sure we can see what that is. All right, so now that it's been expanded out, we're going to solve the same way as we did the previous example. Oftentimes people want their variables on the left-hand side, but really we could have them on either side. So we're going to continue to think of this like a scale. And with that type of thinking in mind, what we're going to do is, if we want to get 4K, what you're going to notice, we're going to get to a shortcut where we end up just moving it over and changing its sign. Okay, but just before we do it that way, let's think about it as if I want to get rid of 4K on the right hand side, I could subtract 4K from both sides of the equation. And what that does is leaves me with 18. Well, 7K minus 4K is 3K, and on the right hand side those two added up to be 0, and we have 1 plus 32, which is 33. We want to get K isolated, so let's move this 18 by subtracting 18 from both sides, and we're left with 3K is equal to 33 minus 18. So we're left with 15, and now just to figure out exactly what K is, then we're going to divide both sides by 3. We get that K is equal to 5, and we would check our work, not by looking at the multiple choice list over here, but by substituting the 5 back in wherever you see K in the equation, and you should get that one side is equal to the other. We would then use this same concept for these other slightly more complex questions that you're seeing right here. All you have to do is expand on both sides before you rearrange, and that's it.